Hello all, welcome to today's webinar. My name is David Findura and I will show you today how to work with moving loads, which is a new functionality in version 26 for SCIA Engineer. So what we'll be looking at today, in the beginning, small introduction. I will explain you the types of the moving load that you can use, and then we will look at some examples. First one will be 1D hole and the second 2D slab, and it will be directly in SCIA Engineer. So what types of moving loads we can use? The first one is type envelope without influence lines and surfaces. You can see here in the generator there is type of generated load cases envelope, and the checkbox compute with influence surfaces is not checked. So it means it is a simple run of the load system on the traffic lane. So no influence lines, no favorable or unfavorable positions of the loads and stuff like this. Just a simple run. Each step has its own results, and when the run is over, we'll create an envelope from all the steps, and we'll create the max and min envelopes. So this is just the simplest one. The second type is type influence lines or surfaces. You can see type of generated load cases here is influence surfaces. So for this one, we have only one position of the load system for minimum and one for maximum, and the user needs to choose manually exact place on the structure where to maximize the component which has been chosen. So the user needs to create a special load case type influence lines or surfaces, and to this load case it is possible to place the unit load, and the user places the unit load on the structure somewhere, and for this exact place on the structure the influence line or surface will be created, and according to this influence line or surface the load system will be placed to maximize or minimize the component. So as a result, we have only two simple load cases, one for minimum and one for maximum. Then the third type is again envelope, but here with the influence lines or surfaces, so again envelope, and the checkbox is checked. This type will in the background do the influence lines or surfaces analysis for each step of the run. So for every step of the run of the load system on the track, we will create unit load, then influence line or surface, place the load system for minimum and maximum position, and then second step, again unit load, influence lines or surfaces, place the load system, and in the end we'll create an envelope from all these influence lines or surfaces. The important thing is that here in this result envelope load case for maximum and minimum, for example, if we choose that we want to maximize moment mx, that we have also the corresponding internal forces, not the maximal internal forces in each node, but for each node we have the maximum mx and then the corresponding internal forces. So I think that's enough for the introduction, and let's start with the examples. So here I have prepared one simple model. It's a hole, and I will show you how to create and work with the moving loads. Let's say I want to create something like a crane load for this hole. The first thing that I need to do is to enable the functionality in the project settings So here in the functionality I need to enable moving loads 1D in this case, and then I will see the commands here in the input panel, or I can use the spotlight, or I can see it also here in the libraries. So the first thing I need to do is to create a traffic lane 1D. So let's start with this one. The traffic lane for 1D is created simply by the selecting 1D members. You can see I selected this member and it already created the traffic lane here. Well, here when I have only one 1D member, it's very simple, but here, for example, I created this member out of 3 1D members. So again, here on this side I can choose this one, and this one, and I will create a traffic lane like this. The direction of the traffic lane, when it is from one 1D member, it follows the x-axis of the local coordinate system, and if I choose more 1D members, the direction of the traffic lane is according to the selection of the members. So if I started with this one and ended this with this one, the direction will be from beginning to the end. So the properties of the traffic lane, here for the 1D traffic lane I can set some offset, because for example for the crane I don't want the crane to go from the very start to the very end, so I want to start in 0.5 meters and end also in 0.5 meters, and you can see that the traffic lane is adapted accordingly. I think it's all to the traffic lane here. When I have the traffic lane defined, I can define a load system 1D. For the load system I can use some load system from the database, for example the load model 71, for example something like this, or I can create my own load system. So the load system, I can change its name, for example something like this, and then I can edit the names of each set. The sets I have here, this is set 1, I can create a new one or copy to new set. I will show you in a while. Then I can create a distributed load and concentrated load. These are the main loads that I can create and add to the load system. Here I have the display of the load system. So for example, if I create some distributed load with length, I don't know, 2 meters, here I can choose the direction of the distributed load. I will leave it to set direction. Also the concentrated load, some example offset, x offset can be 4 meters, and also the direction I can choose whatever I need. So these are my loads for the set 1. I can also create, for example, set 2 and add some more load to the set 2. You can see you have here the reference point for set 1, here is the reference point for set 2. The distance between these two sets is now 0. The distance I can set here in the distance type. I can use variable distance or fixed distance. If I choose fixed and for example 3 meters, you can see the distance between these two sets is 3 meters. If I choose variable, I can set minimal and maximal load distance. So I can say that I want minimum distance 1 meter and maximum distance 5 meters, for example, and the step will be 1 meter. So when the analysis of the moving loads will be done, then it will create all the variations of the load system. So the first one will be load set 1, and the distance of set 2 will be 1 meter. Then it will be set 1 and the distance 2 meters, 3 meters, 4 meters and 5 meters. So every position will be calculated. Yeah, be careful, because the more steps will be done in the analysis, the more time it will take. I can also use the copy to new set. For example, I select set 1, I copy it to set 3, and you can see that it was copied the whole set after the set 2. I can also use the drag and drop and drag the set 2 to the end, for example. So for set 1, there is always these settings also for infinite load. This load is different from the main load, the distributed or concentrated. It's the load that goes over the whole traffic lane. So when I, for example, set the infinite load -2 kilonewtons per meter, I can see it here, and it goes infinitely over the length of the traffic lane. For the infinite load, I can set also the offsets from the set. It is explained here in the picture. So for example, if I choose the external offset, for example half a meter, you can see it's here, external in the beginning half a meter, and in the end, for example 1 meter, you can see it's 1 meter here. So that's it. And the last one are the multipliers. You can see we have multiplier for the load in favorable and unfavorable position. These one are for the main loads, and separately I can choose multiplier for the infinite load in favorable or unfavorable position. This means that when I'm using influence lines or surfaces, the load in favorable position can be, for example, with 0 neglected, and the unfavorable position will be taken into account with multiplier 1 or whatever I set here. The same for the main load. And for each set I can choose the multipliers separately, so each set can have its own multipliers. The work with the tables here is pretty much the same as the other tables in SCIA Engineer, so you can use also with right button click, use these commands: insert line, delete, clear, copy, and so on. So in this way you can create the load systems. I will cancel this one and create something simpler. So for the crane, for example, I can create something like, I don't know, 1 force, and the second force will be 1 meter, and this will be Z direction. And then I will create the second load set, and it will be direction y minus, for example. So I will create something like this in y direction, and the second one, and then I will copy this one, and it will be y positive, so it will be from the other side, for example. So if I have these load systems created, I can go to the moving loads generator. So for the generator, here, as I said in the beginning in the introduction, I can choose the name, and I can choose the type of the generated load cases, envelopes or influence lines. Here I will show envelopes without the influence lines at first. So the first thing I need to choose is the traffic lane. I will choose both traffic lanes for the run of the load systems. Here I can modify the step for the load system run. I will leave it to 1. Be careful with the step, because again, the more steps, the more calculation time. Then I can choose the load group to which will be the generated load cases added, and also I can choose if the load on the traffic lane should be partial or complete. It means that the partial means that the load system doesn't need to be on the track entirely, and the complete, it means that after the entire load system is on the track, it will be the step 1. The partial would be used, for example, for bridges, because the train or the traffic can run on the bridge also partially, but for the crane load there will be the type complete, because the load cannot go out of the hole partially. It needs to be completely on the traffic lane. Then here the checkbox I already explained. Here for each traffic lane that was here inputted, I need to choose load systems. So for the first traffic lane I will choose the Z load system and Y load system, and for the second one I will choose the same. Now important thing is the synchronization group. Here is none for each load system. It means that all the load systems can run on the traffic line separately and not synchronized. So each position, each permutation and variation will be taken into account. Again, the calculation time may be very long for many load systems with not synchronized groups. But in this case, for the crane, I know that it will be all synchronized, because the crane is just one, or there can be 2 cranes of course, but it goes together. So for this one I will choose synchronization group 1 for all the load systems. So I'm saying that the loads are going over the track together. If I need to, I can also set eccentricities for the load systems on the traffic lane. I will leave it to 0 here. Then the last thing is to select the components for which I need to generate the load cases. I need to choose at least one, or I can choose all of them, and it will create load cases for each one, 2 load cases, maximum and minimum. I will choose here, for example, at the moment my. Okay, and I can also copy this one, and I can choose, instead of negative, I can choose positive, so I have also the opposite direction. Yeah, so here I need to also choose one, and now I have the both direction of the Y load. Okay, so if I have set everything like this, I can go to calculation and calculate the linear calculation. You can see that here are the CA, the generator entities calculated. Then I can look at the load cases, and I see that the generator created these 4 load cases. This is the first one, minimum and maximum, and this is the second one, minimum and maximum. I could have used nicer names, but yeah, it's CA and CA1 now. For these load cases, I can also see the results. So, for example, I can look at the internal forces, and here in load cases I see the results for each load case. So for example, for maximum moment, I see the results. The same for minimum, I see the results. For the 1D, I can also see the moving load 1D envelope, and there are these 2 generator entities, and for the CA is the same result as I now showed, but it's together in the envelope. So it's the maximum and minimum together. So you can see the whole envelope of the load system run. I can also look at the other internal forces if I want. I can also look at the deformations, stresses, and stuff like this. Of course, these load cases I can use to combinations and also classes. So I can use the load groups. I can choose the load group and use it to combine it with the other loads to combinations. So I guess that's it for the 1D moving load and the first type, which is the envelope without influence lines. And I will move to the second example, which is 2D slab, and I will show you the type influence lines. So here I prepared again simple structure. It's just slab with 3 fields. And now I want to use the type influence lines. So first, what I want to do is the special load case. I need to go to load cases. I create a new one. I will say it is influence, and I will choose the load type influence surface. For the influence surface, I can choose entity if I want to maximize the internal force, deformation, or reaction. I will stay in internal force, and again choose the entity. I will stay in moment mx. So if I create this special load case, I can add a unit deformation of 2D member into this load case. I can only define this unit deformation to the special load case. You can see the other loads are disabled, and I can also choose only one unit deformation per load case. So I will click on the unit deformation, and now I need to choose the exact place on the structure where I want to maximize the moment mx as I have chosen. So I will say, to have it simple, that I want the maximum moment in the middle of the middle span here. So I will place the unit load here in the middle. You can see I am not able to add more unit loads or any loads in this special load case. So now I defined that I want to maximize the mx moment here in this exact place on the structure. Then, of course, I need to define the traffic lane. Traffic lane 2D, you define the traffic lane 2D using these tools. I think you all know how it works. So, for example, I can use spline or whatever I want, or some arcs, and I can select line and stuff like this. So to have it simple, I will delete this one and I will create a straight one in the middle for the demonstration. So I created this 2D traffic lane. Sorry. In the 2D traffic lane, there is an option to select allocation, because I can have some more slab structures, or I don't know. So I can select allocation to which slab the traffic lane is allocated. I can do it manually like this, or I can do allocate automatically, and it will choose all the according slabs. If I look at these three all are selected. You don't have to allocate it here manually or automatically. If you don't want to, it will be allocated automatically every time before the calculation. So that's the traffic lane. Then again, I need to create the load system 2D. The workflow and basically the load systems and moving loads 1D and 2D work very similarly, so I won't explain everything again. For the load system 2D, we have only surface load, so I can add some surface load, for example 50 kilonewtons, and I see the shape and the reference point, and this is the x-axis. So I will say it will be, for example, 0.5 and here 0.5. So I have the surface load like this. For the surface load, I can also choose the load distribution thickness and angle. So if I say that the load distribution thickness according to this picture here is, for example, 0.2 meters, it will automatically take the load and recalculate the load according to the area of the distribution here. So you can use it for some bridges or stuff like this. I will not use it now for the example. And the next one what I want to show you is the infinite surface load. It's similar to the infinite load in the 1D, but here for the infinite surface load, for example, I need to also define the lane width. So here I need to define some lane width, let's say 3 meters, and it will create 3 meters wide infinite load. Then the internal external offsets, it is the same as for 1D. The multipliers also the same as for 1D, and also the work with the dialog is the same. You can also choose the direction, you can create more sets, the distances between the sets and stuff like this. So yeah, let's create maybe one more just to demonstrate. For the second set I will use, for example, fixed distance like this, and I have 2 sets and the infinite load. Okay, so I have the load system like this created, and I can go to the moving loads generator. So in the generator I will choose the type of generated load cases in influence surfaces. In this type I need to choose the influence line. That means the special load case where I define the unit load and its position. Here I can choose the load case to influence that I created, and the same as the envelopes I need to choose the traffic lane, and for each chosen traffic lane I need to choose the load system. For the load system, again, synchronization group and eccentricity. Now I have only one load system, so I won't synchronize it. Here again the step, load group and the load on traffic lane is partial. Now it doesn't matter for this one, or I want to be partial for the bridge. So with the generator set like this, I can close it and I can calculate it. It should be very quick in this case. And the first thing I can look at is maybe the influence surface itself. I can go to results and I can use, for example, 3D deformations. I will use wireframe and I will choose the load case to influence. That is the one that I created, the special load case, and I can see in this one the shape of the influence surface here. That here is the unit load that I placed there, and this is the shape of the influence surface that was used for the analysis of the load positions. The second one that I can look at is the surface load and the load positions that were used for the load cases. You can see again the generator created 2 load cases, the influence surface minimum and maximum for my chosen generator entity. So here in the surface loads I can choose, for example, the maximal, and I can see the position of the load system that were chosen for the maximum moment here in this place. Here for the minimum, I see that this is the position of the load for the minimal moment mx in this place. You can see that the infinite load is the same over the whole structure here. Maybe for the better example, we can see what it does when I change the multiplier. So for infinite load, for example, I want to neglect it in the favorable position. So I say that in the favorable position don't place the infinite load. So when I set it like this, I need of course to recalculate the project. And now when I look at the load positions, for example for maximum, I can see that here where the position was favorable, there is no infinite load, and for example for minimum, you can see that here is also no infinite load, because it was the favorable position for the minimal moment in this place. Of course, I can see all the results, the internal forces, stresses, deformations, and all results for each load case. So I can go to, for example, maximum. I can go to moment mx, and I see the results. So what else? I hope I have said everything. So this is the type influence lines or surfaces, and the last one is type envelopes with influence lines or surfaces. So in this type, you can imagine that this special load case is in the background created for each step of the load system run on the structure. So the influence lines are created, or in this case influence surfaces, and for each step is a different position of the load system according to the influence surface, also with the neglecting or taking into account the multipliers, and in the end there is an envelope from all these steps created. So let's see how to do it. You can simply create a second type of the moving load generator. You can name it, I don't know, an envelope type test. I will leave the envelope here, and I will leave compute with influence surfaces checked on. Again, I will select the traffic lane. I can choose the step, load group, load on traffic lane. I will leave it as it is here, and for the traffic lane I need to choose the load system. Here again I can choose the components. I will choose mx and the shear force, for example, and maybe to see the difference I will also copy it, and here in the second one I will use it without the influence lines. I will say it's no influence lines. Okay, so I will close it, and I need to recalculate it all, so we can look at the results. And it shouldn't take long. In the calculation you see that for the second one there are many analyses. These are all the steps or the influence lines for each step analyzed. So of course the envelope with the influence lines, depending on the step and depending on the load system and length of the track, it can take, of course, more time to calculate. So in the load cases, I see that I have all the load cases generated. These are the first ones, the influence lines, and here I have the envelopes. The envelope type test, mx min, mx max, shear forces, here moments, and shear forces for the type no influence. And of course I can look at the results. Yeah, just one thing, the surface loads, we are not able to show the positions of the loads for the envelopes for now. For these envelopes we show every time just the first step of the run. We are working on it, and in the next version we should be able to show somehow all the steps of the run of the load systems on the track, but now we show only the first one for each envelope. But for the results I can see that for the envelope, for example, moment max with influence lines, if I see the moment, I see the value 38.4, and if I go to influence surface that I created before by hand, you can see it's more or less the same in the middle of the span. So these results are okay, but of course if you look at the envelope with no influence lines and the maximal moment, it should be, it's not so much, but it is a little less, because there is no use of multipliers for the favorable position of the infinite load. Okay, so these are the results, and I guess that's all that I wanted to show you today. Maybe one last note. In the current state, in the version 26, we are not able to use the moving loads for construction stages, but we are working on it, and it should be also possible to use it in version 27 also with construction stages. So I guess it's all. Thank you for your attention. If you have any other questions, you can reach our support, or you can put your questions here, and I will try to answer all of them. Or of course our support team is ready for your questions. Thank you, and have a nice rest of the day.